All right, one last problem. This one's an application. It says a garden measures 12 feet by 16 feet, and a uniform border around the garden increases the garden's total area to 357 square feet. What is the width of the border? Well, let's get a picture of this thing going on so we can kind of set things up for ourselves. So we've got this garden whose measurements right here is 12 feet by 16 feet. And then we put a uniform border. That means that we're going to put a border of some regular size all the way around the garden, right? So we want it to measure the same thing all the way around. I know this doesn't quite look like it here. I'll see if I can straighten that out just a little bit. Looks a little bit better. Let's see, what can we do here? Come on now. Get this thing to move just a little bit. There we go. Okay, we want a nice uniform border all the way around. So how do we get it? Well, right here we're going to say a couple of things. First of all, we know that this is going to be 16 feet and 12 feet. And area, of course, is equal to length times width. But we've increased the size of the border, and we said that we're going to get 357 square feet if we increase by this unknown border amount. Well, what's the border? Well, let's call its width x, right? So everywhere you look at this border, its width is the same with x. So what does that make our actual width? Well, we've got two x's, one above and one below here on our width side, and we've got two x's, one on each side of that 16. So what do we really have? Well, it looks like we've actually got 12 added to 2x for the length of our garden along with the border, and 16 added to 2x as our length right here. Okay, so we've got length and width. So 357 square feet will equal, well, we're going to have to multiply this out. 12 times 16. 12 times 16. All right, well, I know that 12 times 6 is 72, and 12 times 10 is equal to 120. So if I add those two together, I get 9 and I get 1 right here. So we've got to get 192 plus 24x, when we multiply our outer terms, plus 32x when we multiply our two inner terms, plus 4x squared. And so let's put together some of our terms right here to simplify this whole thing. We actually have 357, 192, 24 and 32, that's 56x plus 4x squared. But to solve this equation, we're going to have to set it equal to 0. So that means we're going to have to subtract our 357 from both sides. Since 357 is negative and it's the larger of the two values, our result should be negative. So let's see, 357, its difference between that and 192 is 5. 15 minus 9 is going to be 6. This is a 2. 2 minus 1 is 1. So we're going to have 4x squared from our first term plus 56 from our second term, 56x, minus 165 equals 0. So now we need to work out this factorization. 456 and 165 do not share our greatest common factor, so we're going to have to work on our factorization right here that's going to give us this. Well, this should be an interesting one because 165 is not one of those easy numbers that we can just factor apart right here. However, we can get a pair of factors and do this by grouping perhaps. Let's try it out. If I take 165 times 4, the constant times my leading coefficient, I'm going to get 5 times 4, 20. That's a 2. 6 times 4 would be 24 plus 2, that'd be 26. 1 times 4 is 4 plus 2, that'd be 6. So 660, we need two factors of negative 660 whose sum is positive 56. Well, let's see what can we do right here. We know this is the same thing as 66 and 10. So we could say it's negative 10 and positive 66, right? And that seems to work. So let's see. Let's use this pair to split up our middle term. All right, so a little bit of factorization work on the side. 4x squared plus 56x minus 165 becomes 4x squared plus 66x minus 10x minus 165. So now let's see what we can get right here. From our first two terms, 2x would factor out, and that would give us 2x plus 66 divided by 2 would be 33. So we need to see what we can get from this next term and get 33. Well, if we factor out 5 minus 5, let's see. This would be 2x right here. And 165 divided by 5? Well, let's see, doing my numbers on the side like everybody else ever does. It's 5 right here. See, 3 goes into 16 5 times. That's 15. Subtract 1. That's 1 and 5. That's 5 times. 3 times 55? Ooh, wait a minute. Why am I dividing by 3? Because I'm having too good a day. Nope. We should be dividing by 5. Right? 5 into 165. 5 goes into 16 3 times. That gives me 15. Subtract away the 15. That gives us 15 again. 33, that divides evenly, leaving us with a remainder of 0. So that's minus plus 33 this time. Hey, lo and behold, there's our factorization, right? 2x plus 33 and 2x minus 5. So let's see what we can use right here. Our factorization, 2x plus 33, and our factorization 2x plus, minus 5 here. Let's be careful. Professor Peoples, be careful. Minus 5. Well, this first one right here, if we take 2x plus 33 and set it equal to 0, we're going to get a negative number. If you don't see that, of course, subtract 33 from both sides and then divide by 2, and you're going to find x is equal to negative 8.5. Well, we can't have negative 8.5. That's not going to work. We can't have negative dimensions, so this is not an answer. What about the other one? Well, let's see. 2x minus 5 is equal to 0 when 2x is equal to 5. And dividing both sides by 2 gives me 5 halves, which is the same thing as saying 2.5. So our border looks like it should be 2.5 feet wide on every side. And that's our answer. Everybody's happy. Good luck on the homework.